I want to bring you up, want to start with the phrase, and you probably have heard of it. Space, the final frontier. It was the opening phrase of one of my favorite, basically the fourth favorite series during my childhood. Star Trek, The Next Generation. And you say the fourth? What were the other three? Well, basically, Mutant Ninja Turtles, the Power Rangers, and My Little Pony, of course. However, I am a Star Trek fan. And who of you likes Star Trek? Who of you is more of a Star Wars kind of? I'm still with you. I love that too. So don't worry. I'm not gonna do the old school bashing Star Trek versus Star Wars. But there is a thing with Star Trek that interests me so much because, you know, it can be true, right? I mean, if you look at Star Wars, it's a fictional thing. There's not even an Earth in it or something like that. But it's a great storyline. However, if you look at Star Trek, it could be at the end of the end of days that we have starships or kind of that. If you look at Star Trek and say the OG series, you saw a couple of things. For instance, did you know that they have this sliding doors, opening and sliding doors back? Look closely at one of the episodes and you will see that they're not really synchronous because at that time they didn't have that. There were people behind that and actually pulling and pushing the doors, which makes it interesting because if you will look at, for instance, the computers they were using in the original series of Star Trek, you know, the Star Trek with Spock, it's kind of this. To be honest, if this is the future, I'm sorry, but I don't want to be in it. I mean, if I give this to my little cousin, he would look at me like, dude, what is this? I've got a smartphone. Go away, old man. Anyway, there's one other thing that fascinates me about Star Trek, and that is this. Teleporting. It would be amazing to be on the stage, like here, and instantly be back at home without driving for an hour or 2 hours or even more. I thought COVID would solve all of this, but now we're all back on the road. But let us take us into this technology. Of course, it's fictional. But what we're trying to do is we try to decompose an object, the human, send it over some stream to the other side of the world maybe, and compose the human back again. That is basically what we do in Java if we use serialization and deserialization. But can you imagine if something goes wrong with this, that your ear is not on the right spot, but on the top of your head or something like that? That would be funny for us, not for the person who actually has that. However, these problems can exist, or some weird things can exist if we do serialize and deserialize in Java. Well, you've seen me on stage today before. This is me. I'm Brian. I'm a developer advocate for Sneak. That means I do some Java programming and I email a lot. I'm a Java champion, do some stuff in the community. Oh, really? Yes, I do. That. However, that is not what we're going to talk about. We're going to talk about deserialization, not specifically only the Java deserialization, but also more ways of deserializing your data back and forward. Because you know how Java's custom deserialization and serialization framework is, what the nickname is of it? This sounds like early Christmas, but it's not a good thing. The gift that keeps on giving, because it is the source of a lot of potentially and actual harmful features, or, well, not so much features that went into the Java framework. Okay, some basic knowledge to make sure that we're all at the same page. We have an object, we compile it into a stream, and we can store it either in a file or maybe send it over the line. That is basically what serialization is. You probably already guessed it. Deserialization is the other way around. So we have a file with that serialized data. We get the byte stream out of it, and we recompose the object. All right, so let's look at some code. This is my value object. And there are a few things that are important if we want to do serialization in general. First of all, we need to implement serializable. And that's for a reason. They tried to make it simple. And, well, successful, but also a simple way to manipulate the stuff. And what happens is, look at this constructor. In this constructor, we set the value, and that is one of the parameters. But the second field, the side effect, is actually set during construction. Okay, so let's go into serialization of this object. We have this object again, and we serialize it. Nothing's wrong with it, right? But what serialization does in general is we get the values of the field in the state that they are. And they are based on reflection. Okay, you would say. But the point is, if we look at a serialized object, say I have this object, this value object, and this value object says something like hi is the value. Well, if we look at it with a hex editor or something like that, it looks something like this. And you see at the end that it's two characters, the H and the I. Well, if I can read this, that means that I can easily do some sort of man-in-the-middle attack, grab that data or grab that object and change it into hello. And then you would say like, yeah, fair enough, point. We can make sure we can validate the stuff, right? Maybe. But one thing is, if you have that object and it's actually the right object that you want to deserialize, you're not sure if the object was actually the original object because, hey, we can just simply change it. That can already be a bad thing because we don't know what actually happens afterwards. But okay, that is still something we can cope with. But let's look into deserialization. So we have that same object again. And then we have this. This is what we call, well, this is basically how you deserialize an object in Java. Who of you ever used serialization and deserialization like this? A bunch of you, all right. So then you know, then the harmful thing is the third line in this red outline block. Because when you construct or basically reconstruct the object, it does not use the constructor. It uses the read object. So what does the read object do? Basically, the read object looks in that object input stream, creates an object, and at that point, it's already in memory, and then casts it to the object that I want. So what if the object is not the object I want? I get a class cost exception. However, there are two things that are going wrong here. First of all, we are not using the constructor to recreate the object. So if I have validation in my constructor, it doesn't work. It uses reflection to reflectively put the fields in. Okay. The second thing is that that read object reads the object already before it casts. So if that object is something totally different, it can already set off a few things. And I will show you that in a second. Because now you know what serialization and deserialization is, and we do not use the constructor, basically, but the read object. We need to look into gadgets. And this is my 5th series that I love the most. Who of you recognizes this reference? Thank you, I'm not feeling old anymore. Anyway, what is a gadget? Let's decompose that. I create a gadget over here. And a gadget basically is an object that if you create it, and it can either be via the constructor or something else, it not only sets the fields, but it also sets off a process. Look what I did over here. The constructor, nothing special. the field that I can implement in this gadget is a runnable, so I can actually run that process. But what I did, I overrode a private vinyl void read object, and that's basically the thing that we just use to deserialize stuff. I practically read the object, and I run it. So even though it's not the object, even though it might be an object that I don't want, and I get a class cast exception, we can basically see that this already run. Because, again, if I do this, and you see in the third line I still expect my value object, right? But it's already in memory. So that gadget contains some code, a runnable, and that runnable is already set up. And if you don't believe me, I will show you. So, over here, this is my gadget, exactly the gadget that I showed you. It has a runnable, and I overrode the read object. So what I'm doing here in this example is I'm creating this gadget, and I'm serializing it to a file, gadget.ser. Then I'm going to deserialize that same file. And if we go here, what deserialization does is basically what I showed you before. And we expect actually a value object. Yes? Oh, let's run this one. What we see is if I run this one, and let's run the right one, it's the main. Oh, demo gods, please be with me. What do we have here? Lambda static issue. This wasn't what I was supposed to do. That's not what I wanted. Oh, I get it. It gets the wrong one. This one I need. Example 2 without any parameters. Oh, thank God. So what are the odds? What do we have here? Let me enlarge this for you. You saw that the gadget contains that extra thing, that command that is, in this case, env, right? Over here, env. And that shows me the environment variables of my system. It has the class cast exception because it is actually not the object I'm supposed to be, but because it's already in my memory, and because it's actually already constructed into an object, because of the read value, it already sets off the process, and we have basically a side effect that runs that command. So even though if I accept serialized data in this case, and this data is based on a class that is on my class path that has a side effect like this, that side effect will run if the read object already, if the read object is overridden and the read object sets it off. And then you probably say, yeah, but how bad is that? Who overrides the read object, right? Well, let me get back to you on that in a second. The problem is not so much that single gadget. That single gadget here was just to explain to you what a gadget is. The problem is that if there is a gadget that has overridden the read object and might be able to instance another object and another object and another object, we can create a gadget chain. And then it's get interesting, because in the end of a gadget chain, we are looking for a sync gadget that actually exposes the arbitrary code execution, as we call it. So we need a starting point, and we need an endpoint. And if we connect that, then we have a gadget chain that can do arbitrary code execution. And then you probably say, but yeah, that chain is very hard to find. True, but think about this. How many libraries do you pull into your application? A lot. 80%, almost 90% of the code that you pull in your runnable jar, war, whatever it is not your code. So we can assume that there are so many classes available on the class path that there might be a possibility that such a gadget chain exists. Okay, but then still I need a starting gadget, right? Just avoid that. Well, that is nice, but just take a look at the implementation of HashMap. I can show you what HashMap does, but HashMap, by default, overrides the read object. So we already have our starting gadget. Nice, and it's there in the JDK. I love it. Okay, what is my next step of attacking this? Well, now I need to find a gadget chain, and that is very hard. Trust me, that is very hard. But we've got an app for that. We call it Why So Serial. Hence, well, if I have to explain a joke, it's not funny anymore. What does Why So Serial do? Why So Serial is an open source package, an open source project. And it is a proof of concept tool for generating payloads that exploit unsafe Java object deserialization, exactly what I need. So if you look at what it can do, it can create these chains for you based on certain packages that you might have included. And it can be something like one package. This one is Commons Collection 3.1. But it can also be a combination of multiple packages, like over here. And this tool already creates such chain for you, and you basically can use it to execute a deserialization attack. Love that. Want to try it. What I'm going to do today, I'm going to use the Commons Collection 5. It's the fifth problem in Commons Collections using Commons Collection 3.1. That means I need to have Commons Collection 3.1 on my class path. It needs to be loaded into memory, or else it wouldn't be possible. But hey, if I download a Commons Collections library, I probably download it to use it. So I made a proof of concept of this. I'm using a lazy map just to make sure that I'm actually using Commons Collection map. And what I'm doing here is I'm just reading a payload.ser. Okay, but let's create that payload first. I'm using YSOSerial, the jar I compiled myself, with the Commons Collection 5 entering, and I'm saying touch hello.file. Let's make it a little bit cheesy. Hello.jfile.file, and output it in payload.ser. So if I do this, it's created. Fine, cool. Nothing there. We have a deserialized chain of objects created in the file. Now I will load this file, and I will deserialize it, and I expect, again, a value object, one of the objects I showed you before. Let's run this one, example 3. Okay, it runs. Cool. But what now? Well, let's check back into the terminal. And hey, now I created this file. So basically, by just importing this library, by using this library, you are already exposed to a deserialization chain, and I can do something in the background. That is interesting, because that is just one library. But can you imagine what happens if you have a ton of libraries? Who is using Spring Boot? Do you have any clue how many jars Spring Boot includes to your application? One too many, basically. But seriously, it's a lot. So just to make an example of this, you see, if I import the wrong version of a library, we are available, or we are already vulnerable to such an attack, which is interesting because I don't see any output in it, but I see that the file is already created. But if I can create a file, I might also be able to create a script, run that script on the background, and may do harmful things to you. Interesting. So I bluntly copied this slide. This is the exact slide from Ian Haken. He is a security analyst from Netflix. And they did this research for gadget change. They created a tool to do that, an internal tool to do that. And I'm not pretty sure if the tool still exists or is still maintained. But the fact what they did is they provided it on their own services. And what they saw is that with a combination of this, in this case, of 6 libraries combined with a JRE, we can create such a gadget chain. So the combination of a ThoughtWorks Extreme, something in Commons configuration, some closure stuff, some internal Netflix stuff, like all these bits and pieces all together could create such a gadget chain. And then it's just waiting until disaster happens. It's still very hard to find such a gadget chain, but if somebody found it, publishes it, and puts it in a tool like YSOSerial, ta-da! Oh, by the way, don't use YSOSerial to hack, use it for test purposes, right? Okay, so this is basically interesting, but what about records in Java 16, 17, whatever? I mean, if you are on Java 16, you should update to Java 17, period. But what about that? We have records now, right? This solves the whole problem. Well, yes and no. As a proper consultant, I would say it depends. I wrote a record here, a to value. And what I did specifically, I overrode the constructor to have the side effect of a println. So what happens is that a record already helps you a bit. As in, deserialization of a record doesn't circumvent or doesn't go around the constructor, but actually uses the constructor to create that, recreate that object. So say this is my application, or this is the piece of code that I want to do. Basically, I have a to value, having 1 and 2. I am serializing it to a toValue.ser. I print out that it's serializing, and then I deserialize it, just in the regular way. This is basically the output. So it creates the to value, cool. It serializes, and by deserialization, you see that the constructor is actually used. So even if you overriding the read object thing is not a thing anymore, because with records, we use the actual constructor. That means if you have validation methods in there to see if your object is valid, it will actually get executed. That is already a big okay. However, we're still doing this. So that means that every other Pojo in your application is still vulnerable to it. So does it make sense to have records? Yes, as long as you don't put in other objects that can contain a gadget chain, or put in libraries at all. So yes, it helps if everybody just does have records, but basically, in the end, you're still vulnerable to the same thing. Even though people say records will be safer, yeah, record itself will be safer, but it doesn't help you in the bigger picture. So, that was boring, but what can we do? How should we solve this? First of all, try to avoid serialization in Java at all. But if you need to do serialization, for instance, you need to, say you have an abstract class that you need to implement or something, or you need to extend, and it's serializable. What you can do is you can override the read object. So if it gets written, or if it gets read into memory, it directly throws an exception. This way you prevent that something goes wrong. But say we actually depend on serialization in Java, and then I mean the custom serialization. One thing you can do is use the Apache Commons library. And Apache Commons library, what it does, it uses the validating object input stream. And the validating object input stream basically looks into the input stream and sees if what the actual object is that you're trying to deserialize, instead of deserializing this and casting it and waiting for a class cast exception. In this case, I can create an accept list or a decline list. In this way, I know that for this piece of code, only my value object class is cool. However, there are also ways in Java to do this, in plain Java without any libraries. And that's basically in JAP 2.19 and JAP 4.15. In JAP 2.19, which was already released in Java 9, if I'm not mistaken, the folks introduced the object input filter. And you can create a filter by using a string, like you see over here. And basically what I say over here, I only accept the value object for this specific stream and decline everything else. This is already helpful, but JAP 4.15, and that's the JAP that is released with Java 17, helps it a little bit more, because there is a problem with JAP 2.19. It's actually, it's useful, but it's not really useful. Let me get to this. You can set such a filter globally to your whole application. That's cool. But once you set a filter to a specific stream, which is also possible, like I do here, it basically overrides the global filter. That's not what we want. Also, if you are depending on libraries that do serialization for you, or use serialization, even though you set a global filter, you're not sure what happens, because maybe in that library, they set a filter specifically on the stream, and they might override it. So you're not sure what happens, and it's not really a feasible way to work. What you can do in Java 17 is use the new stuff that they created in JEP 4.15. So, what I do here, I'm creating a filter, and filters you can create filters in a very much easy way by creating such an allow filter in this way and giving it a lambda. And I can now say, hey, let's look at the package name, and if it equals something like this, I want to allow it or I want to disallow it. I set this filter here to the global configuration, and I can do this either in code or by setting a JVM parameter. But what I can do as well, I can set a serial filter factory. And it took me some time to read the JEP and understand what they mean. But in that factory, what I do is I give it a lambda or a function and telling it how to combine the existing filter with a new filter that is specific to that stream or to that context. So say I have a global filter and I have an extra filter somewhere to that, in that stream. I can decide with this factory, I can decide how we should work with that. And in this case, what I say is, hey, we have two filters and we merge it in the standard way. So that means that if I set a filter over here on my specific stream, I know that my global filter is still in place. A lot of stuff. But if you want to know more about this, I wrote a blog post about it with some examples that you can try it out yourself. And then probably a lot of people say, yeah, nice, Java serialization, Java deserialization, blah, 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 but I'm using JSON, right? Who's using JSON to serialize and deserialize data? Thank you, I appreciate that. So let's go into JSON deserialization with JSON, because JSON is the main library which is delivered to you by Spring Boot to deserialize and serialize your stuff. How many of you actually know how this works? That's a lot. Well, great, we just use it because Stack Overflow told me so. Anyhow, oh, that's not what I want to do. Oh, my variable is still there, cool. So what you can do in JSON is normally you have an object mapper. And with that object mapper, you can use that object mapper to read any JSON, right? But there's one thing. You can set default typing. Who of you heard of default typing? One. That's already one good answer. With default typing, luckily it's something that is not by default true. But with default typing, you can basically set automatic typing on. Let's call it that. Say I have an animal, and I'm not sure what that animal is, if it's a cat or a dog. Both the cat and the dog are animals, and if I'm deserializing, I'm not sure, and I want to be open for that. If I set it like this, it is allowed. It will deserialize and look for it, and it accepts the cat and the dog because they're both animals. Let's take that to the extreme. So we have this object mapper. We globally set that enable default typing is true, and we read that value. And this value, in this case, is person. But instead of a name, which normally should be a string, or an age, well, the age is actually a type. But the object of the name is an object now. So basically, I took this to the extreme, and I accept everything. If I just do this, and I deserialize this JSON, this will be perfectly fine. But this will be as well. This means because it's an object, everything is an object. and I can deserialize everything that is over there and put it in, and in this case, it's a gadget again, and it automatically executes for me. You can do default typing either globally, like I do here, or you see that JSON annotation, and I put, or you can see that JSON annotation that I put here, so you can do this by field. So over here, I have the same example, and I'm basically trying to deserialize my not evil.json, which is my normal JSON file, which I showed you, right? So by running this one, this will go perfectly fine. No worries, default typing doesn't actually involve me. It doesn't, I just have the things that I want. It basically says, hey, it's me, and I'm 37 years old. Cool. So let's move to that evil.json. And my evil.json uses the example for gadget, and the example for gadget is basically the same gadget I showed you before in the other thing. It runs a runnable when the constructor is there. If I call the constructor, it actually gets a command and it runs the command. These kind of classes exist. So if I run this one, you will now see that as a side effect, I've executed an ls-l. So, okay. You probably would say, yeah, but default typing is off by default, right? Yes, it is. But are you the only one who is using or reusing your JSON mappers? Or is your library as well? Secondly, how many of these problems are there in JSON? Well, I checked the database, and these are the problems for a subset of the problems from 2020 and 2021, and these are all deserialization issues with JSON data binding. However, the folks at JSON data binding do a really good job. First of all, they enable default typing, but they also actively, if they find another gadget that can be influenced by this, they blacklist it or blocklist it, to be more woke. By blocking it specifically, they have to update a new version. So one of the things you should be doing is, if you're using either Spring Boot or your JSON data binding that is there, like directly, please be aware that you update to the latest version, because these folks do a great job, but you don't want to be caught in a crossfire because there is an object. For instance, a year ago, there was a problem with an cache object that could be used as a starting gadget to execute a gadget chain. And that is something that is well and commonly used in Spring Boot, for instance. One of the things you shouldn't be doing yourself is, for instance, do not enable default typing and update your libraries. But just using JSON and just using JSON doesn't solve the problem. You have to be aware of what these things do. So let's go into two other examples. I have enough time. Let's go into YAML, everybody's favorite way of deserializing stuff, isn't it? Okay, let me put it. Who doesn't like YAML so much as I do? Well, I won't say I hate it, but I dislike YAML. Who dislikes YAML as well? So that means that 40% likes YAML. Who likes YAML? 5, 6, 7, so the rest is asleep. Okay, cool. These are not particular problems with gadget chains, but other things that can go wrong with deserialization stuff. Say YAML. If I want to serialize and deserialize YAML, I probably use one of the most common libraries called SnakeYAML. And again, that is provided to you in every Spring Boot distribution. So let's go to an actual application. Well, this one. Let me run this application. And I'm using a little bit an outdated version of SnakeYAML. Let's hope it runs. Cool. it's an application I wrote for a workshop, and it has a bunch of users in it, and you search users, you can add users, and one of the things you can do, you can import an XML file, or in this case, also a YAML file to include new users. If a YAML file looks like this, and I will enlarge it in a second, this is the normal way of how it accepts the YAML file. This is pretty clear, right? I'm introducing a new user. Oh, don't ever do the password like this, but hey, I work at a security company. This is perfectly safe. However, this is the okay way of doing this, and this works. But what if my YAML file looks like this? This is what we call a billion laughs attack. And what I'm doing here is one of the things that I can do in YAML, and basically this is also possible in XML, but all the XML parsers in Java already prevent this. But this is an actual problem that consists already for years in XML, but it's also possible in YAML. Because what we can do in YAML, we can create variables and we can create anchors. I'm not sure if anchor is the right word, but links to that variable. What I'm doing here is I'm creating LOL1 with a link LOL1. And it contains a list of strings with LOL, 10 to be precise. Then I create LOL2, which basically contains a list of lists that contains LOL. So 10 times 10. And I do this over and over and over and over and over again. And at LOLZ, I basically have a billion times LOL. That's why they call this a billion laughs attack. And what I'm doing here, instead of the first name, I'm calling LOLZ. What happens? All these objects will be loaded into memory. But how big is your memory? That depends. Hopefully you're not running on a cloud instance, because you pay for this. However, let me show you what happens. Let me choose the file. Let me go to the correct one first. Examples, laughs 2. So if I'm doing this and I'm submitting this, this will run for a while. And this is okay because I'm a single user. I'm the only user that we're working with this. And what can possibly go wrong? But it loads all the objects into memory. And at a certain point, my heap is just full. So it will basically go into a memory problem. That's still loading, and it keeps loading, and it keeps loading. But trust me, at a certain, here we have it. So can you imagine what happened if you work at Amazon or something like that on Black Friday, and there are a trillion, gazillion kind of requests per second, and the heap falls away of a few nodes? It's not what you want. Basically, this can end up in a denial of service. And the thing is, if you update to the right version, because this is 125, and from 126, what they did is they just look at the amount of recursive calls, and it can be just a certain number of it. So that means that your heap will not get filled up. I can update the version and show you, and then it will say like, hey, you do more than 50 traversions, and that's not allowed anymore. So we cut it off, you get an exception, but your application is still running. So by using the wrong version of a library, I can get a denial of service. Interesting. So, okay, we covered YAML. Let's cover one of our other favorite topics, XML. And I already told you that XML had this problem before, but actually all XML parsers already took care of this, but the folks that created SnakeYAML didn't until recently. Again, good job, because they did. What can happen with XML? Well, one of the things you can do if you deserialize XML, because that is what marshalling and unmarshalling is, serializing and deserializing, all XML parsers in Java are vulnerable to external entities attacks. Let me show you. If you're not aware what an external entity is, I will basically show you now. So, similar to uploading a YAML file, I can also upload an XML file. Am I in the right directory? Nope. Nope. Where is it? Here is it. Nice. All right. So a good XML file in this case would look like this. So again, basically the same arguments, two superheroes with a comment. Nothing special. But now I can do things like this. And this is getting interesting. You see what I do here? I have a doc type entity. And trust me if I say every parser in Java is vulnerable for this by default. You can circumvent it, or you can solve it, but by default, this is vulnerable to this. What I'm doing is I'm creating an external entity using a doc type, and I point it to a file on my system. And the reason that this normally can happen is you can include things like XSDs or whatever files to look into your XML and validate things. That's the original reason for this. But it also allows me to go into other files on the system if I know where they are. For instance, the passwd file. So if I know where the file is, okay. What I'm doing is I bind it to the variable xxe. And instead of putting out a comment here, I'm actually putting out xse. So that means that if I upload this XML, and I'm using the sax parser that is there available for you to grab in Java, and I will show you the code in a second. And I'm using the user bad XML I showed you. If I submit it, what I see is that the comments now contain the body of my passwd file. So outside of the box of my web server, because this is a Spring Boot application, I can access files on the system that might be open or not. Depends on what your user privileges are. But side question, do you know what the default privileges of a Docker containers are? Root, exactly. Check your Docker files if you run them with a specific user or not. Because if you put this in your Docker file and you might have other things in it, I can access them in this way. So you now disclose information that is not actually you want to disclose it to any other people. Simple thing, what you need to do is you just need to set a few... Oh, still there? It was black on my screen here. You simply need to set a few things. So if I go to my XML processor, and this is a very naive way of using the sax processor. It's still there, right? Yeah, cool. And what I can do, I can set, for instance, on the factory, and yes, I put a note here. I can set, for instance, set the feature that I want to disable, or I do not want to enable external entities. So if I do this over here, and I say to this factory, using this string like external general entities, are they allowed? Set them to false, and it doesn't work anymore. Funny thing is that I didn't know about this until I was researching XML for some reason. God knows why. But the point is, in very old or older applications, we're still using some form of XML, maybe even SOAP connections or something like that, and we parse it into objects. So if you allow XML files from the outside and you parse it to objects or something like that, I can do these kind of tricks. Unless you set the proper features. So you can disable this, but by default, it is on. And that counts for the DOM parser, that counts for the SAX parser, and a lot of other parsers that are there out in the outside world. Okay, so I showed you a few problems why deserialization is something you have to be aware of and not just blindly do. Let me give a recap. First of all, do not deserialize input from unknown sources. And that sounds okay. Like, yeah, obvious, dude. But think about it. If you deserialize object that might be in a data store, are you the only one that can access that data store? If not, I'm not attacking your application, I'm attacking your data store. And in the end, it will traverse back to your application. That holds for any type of validation of the object. Basically, try to prevent just the Java's custom serialization as much as possible. If you don't need to use it, don't use it. A lot of things like the HashMap override the read object value already, and that is because I think it is to make sure that it's still compatible with older versions. I'm not sure what the reason is, but that is probably the reason why. But I can already give you HashMap is one of these entry gadgets for Java deserialization. But if you don't need to use it, if your application is not using it, don't use it yourself. Make sure that you use filters if you still need to use serialization for some reason. Also, it's good to set a filter if you are aware of what your libraries, what a library that you use is using. If you're using JSON, XML, or YAML marshalers, by default, they might have issues, like I showed you today. So be aware of how these things work. Don't just blindly use them. Read the documentation. I mean, that sounds probably weird, but it's all there. But also make sure that you update these insecure default values if they are there. And also make sure that you update to newer versions of it. Because I know we probably work at banks or at government agencies or at insurance companies, and they say, if it works, don't touch it. But if somebody found out that, for instance, the XML parser that you're using doesn't have the the external entities disabled, somebody might get in. So make sure that you update these insecure libraries and scan your applications for known vulnerabilities in libraries. For instance, if I would scan my application with, well, let's say the OWASP scanner or Sneak scanner, it will say to me, like, hey, you're using Commons Collection 3.1. We know that in that library itself, it already contains a gadget chain. If it scans the other application with the YAML problem, it says, hey, you're using 1.25 of Snake YAML, update to 1.26, and then you're done with it. So the steps are easy, but you need to take them. Not just trust Stack Overflow or any blog post. Be aware of what you use and try to prevent problems that you don't want to encounter. That is it for now. I think beers are cold. Thank you so much.